In today's lesson, we will be learning about two special right triangles. The first type of special right triangle is the 45-45-90 triangle. In a 45-45-90 triangle, both legs are congruent and the length of the hypotenuse is square root of 2 times the length of the leg. In our triangle, our hypotenuse is always across from the right angle. That means our other two sides are our legs. And since two of our angles are 45 degrees, meaning they are congruent angles, the sides opposite from them are congruent. So this is a right isosceles triangle. We're going to take a look at what happens to the hypotenuse in a right isosceles triangle. So here I have triangle ABC, and it is a 45-45-90. Since this is a right triangle, I can apply the Pythagorean theorem, which is a squared plus b squared is equal to c squared, where c is the hypotenuse. So the x, or the sides with the x, are like our A and our B. So this would look like x squared plus x squared is equal to c squared. X squared plus x squared gives us a 2x squared equals c squared. If I want to solve for the hypotenuse or solve for c, I need to take the square root of both sides. So on the right, I'm just left with c. On the left, I can't take the square root of 2. It gives me a decimal. So I'm going to leave it under the radical. But the square root of x squared is just x. So it comes out of the radical. So we have c is equal to the square root of 2 times x, which is exactly what our theorem says. Our theorem says that our hypotenuse is equal to the square root of 2 times the length of a leg. So let's practice. On example A and B, we are going to find the hypotenuse. The hypotenuse is across from the right angle. And so the 9 is the length of one of our legs. So the hypotenuse is equal to the square root of 2 times the length of a leg. So since our leg is 9, the hypotenuse is 9 times the square root of 2. Let's try another one. Again, the hypotenuse is equal to the square root of 2 times the length of a leg. Our hypotenuse in example B is this side over here across from the right angle. So this is the length of one of our legs, the 2 times the square root of 2. So our hypotenuse is equal to the square root of 2 times 2 times the square root of 2. If I rearranged this, I could multiply the square root of 2's together. And I know the square root of 2 times the square root of 2 just gives me a 2. So now I have 2 times 2, if I simplify, or 4. So our hypotenuse is 4. Now we are going to practice finding the length of a leg. So in examples A and B, We are given the hypotenuse and we want to find x, which is one of our legs. We're going to use the same formula. So our hypotenuse is equal to the square root of 2 times the length of a leg. Our hypotenuse in example A is 6. So I'm just going to substitute a 6 in for the hypotenuse. Equals square root of 2 times x, since x is our leg. Now to solve for x, I need to divide by the square root of 2 on both sides. So the square root of 2 over the square root of 2 is just 1, so they cancel. So I'm left with x is equal to 6 over the square root of 2. And if you wanted to for this lesson, you can type this into a calculator and get a decimal. This works just fine for now. Example B, same thing. We want to find x, and x is our leg. So our formula is hypotenuse equals the square root of 2 times the length of a leg. Our hypotenuse in example B is 15 times the square root of 6 equals the square root of 2 times x, because x is our leg. Again, to get x by itself, or solve for x, we need to divide both sides by the square root of 2. This cancels. We are left with x equals, now we can simplify this. Just like we can multiply the square roots, what's under the square root together, I can take the square root of 6 divided by the square root of 2 to simplify this. So I would get a 15 times the square root of 3, since the square root of 6 divided by square root of 2 gives me a square root of 3. So here's our x value. Next, we are going to take a look at the 30, 60, 90 triangles. In a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is square root of 3 times the shorter leg. Now our shorter leg is down here by x. This is our short leg. And I know that because it is across from the shortest or the smallest angle. Excuse me. So that means our long leg is across from the 60-degree angle. And again, our hypotenuse is always across from our right angle. We're going to do an example with this. We are asked to find x. Notice x is the hypotenuse of our 30, 60, 90 triangle. Since 6 square root of 3 is across from the 30-degree angle, which is the smallest angle, this is the short leg. So I want the equation that has the hypotenuse and the short leg. And in our theorem, it says that the hypotenuse is equal to 2 times the short leg. Our hypotenuse in this triangle is x, and our short leg is 6 times the square root of 3. 2 times 6 square root of 3 is the same thing as 12 square root of 3. Next example. In this picture, we have two separate 30, 60, 90 triangles. We have a triangle on the left and a triangle on the right. I'm going to find x first. If we just look at the triangle on the right-hand side, x is the short leg of that triangle. And then we are given the long leg, which is 6. This is the long leg of the triangle on the right. So I want the equation that deals with the short leg and the long leg. So our theorem says that our long leg is equal to the square root of 3 times our short leg. We said our long leg, which is right here across from the 60-degree angle, is 6, and our short leg is x. So 6 is equal to the square root of 3 times x. To solve for x, I need to divide both sides by the square root of 3. So x equals 6 divided by the square root of 3. Now I want to find y. Y is on the left-hand triangle. If you notice, y is across from the 30-degree angle. So y is our short leg. Then we also have the length for our long leg over here, which is 6. So we're using the same formula. The long leg is equal to the square root of 3 times our short leg. Our long leg, again, is 6, and our short leg is y. So if we divide both sides by the square root of 3, you'll see that y is the same value as x. We get 6 divided by the square root of 3. And this works for now. If you want to type it in and find a decimal, you may do that. So now we have x and y, and we want to find z. Well, z is the hypotenuse of the triangle on our left-hand side. So the equation, or the part of our theorem that talks about the hypotenuse, gives us the hypotenuse is equal to 2 times the short leg. Z is our hypotenuse on the left-hand triangle. And our short leg would be y. We said that y was 6 divided by the square root of 3. So z is equal to 12 divided by the square root of 3. Or a decimal would work just fine.